Hey guys, in this video we're going to see the basics of plotting or data visualization, and we're going to use Python and Matplotlib to do some basic charts. The data that we're going to use is going to be the New York City Airbnb open data, which is available on Kaggle. And this dataset has the advantage of being some real data, and it's relatively easy to use. So we are going to basically do some exploratory data analysis on it. And this is sometimes or most often should be one of the first steps that you take when you are trying to solve new data science or machine learning problem. So the reason why you want to do some data visualizations and exploratory data analysis is that you want to build basically some kind of intuition about the problem. And this intuition will hopefully help you when you are trying to build a model about the data. So this intuition might give you an idea of what features might be useful when you're building the model, or if the data looks relatively clean, or are there any errors in the data. So I would say that it's some of the most important steps into solving machine learning problems. And I mean, like most of the time when you're solving machine learning problems, you're basically doing data visualization or exploration, then you're doing data pre-processing, and like 10% of the time maybe you're doing the modeling. You're just importing some pre-trained model if you're using deep neural nets, or you're importing something from scikit-learn or some random forest, maybe SVM regression models. And basically the modeling part is like 10% of everything. Most of the time you should focus on the correctly pre-processing your data and understanding, building intuition about the problem using exploratory data analysis. And one of the ways to do that is to do some basic visualizations. The visualizations that I'm going to show you, or the charts that I'm going to show you how you can do them, are pretty basic, but I would say that they take maybe 80 or 90% of the charts that you want to, or type of charts that you want to do when you're solving a real world machine learning problem. Okay, so I'll open a new Google Colab notebook and I'm going to check the runtime. Check that we are using Python 3 and we don't need a hardware accelerator for this one. So this is fine. My notebook is already connected. We have 12 gigabytes of RAM, which is great. And I'm going to pull this away. Next, I'm going to download the data. It's on my Google Drive and it's the same CSV that is available at Kaggle right now. So given this, I'm going to basically do some imports, which are going to be quite a lot actually. Here I'm importing pandas, Seaborn, which is somewhat of a helpful or support library for making good visualizations, and it works in tandem with Matplotlib. NumPy, Peel image, this one we will use for actually displaying an image. PyLab, which is part of the Matplotlib package, and the PyPlot package, which is submodule of Matplotlib. So if we go to the Matplotlib library website, you would see that, and this is basically the most used, or this pretty much the standard library that you're going to use when you are trying to do some plotting in Python. And okay, so you can have a look at the docs. There are very good examples in here. And the next library that we are going to use is the Seaborn. And it's statistical data visualization, and I believe it's made by the team in Stanford University. This one just makes the plots, well, let's say a bit better to look at, and it offers a bit of more plots are available with this library. but we are going to basically stick with the Matplotlib ones in here. Alright, so how do we do this Matplot thing here? The first thing that I'm doing when doing Matplotlib is to say that I want our charts to be inlined. So this means that basically the images of the charts are going to be displayed right in our notebook, and this works on Google Co-op and regular Jupyter WAP notebooks, of course. Then I'm going to do a config which basically says that I want that our charts to be at very high resolution or retina resolution. Next I'm going to use Seaborn to set a style, and I would like the background to be a white grid. I'll choose a color palette which is going to be muted, and I'm going to upscale the font a bit. Okay, so next I'm going to create a color palette which it's a custom set of colors that I'm using, and those are hex colors. It's a custom set of colors that I'm using in most of my tutorials, and I really like those colors because they are very vibrant, and they are just, well, it makes you happy when you look at them. And we can set this palette by creating a color palette from the array of colors. Let me just run this. Set palette. Alright. Let me rerun it. Okay, and the last thing that I'm going to do is to set a default size for the charts, and this will be fixed size or figure size. And this accepts basically a tuple. I believe this is in inches, so this is somewhat related to printing a regular paper, and I want a width of 16 and height of 10. This might be a bit too much. Let's say 12 and 6 because we are zoomed in here. Okay, so this pretty much is all of the setup, and I'm going to use pandas to basically read the file, which is AB for Airbnb NYC CSV file. Alright, and if we take the head of it, you can see that we have actually a lot of columns in here: reviews per month, availability, last review date, number of reviews, minimum nights, price, room type. We have neighborhood group, Brooklyn, Manhattan, and maybe some others. And then we have a more detailed breakdown of the neighborhood. And we also have the host name and the name of the property, I guess. Okay, so next I'm going to do just a basic check on how many rows do we have. We have almost 50k examples, so this should be plenty to do some plotting. Okay, so usually some of the first plots that I do when we have numerical data, at least, is to do some sort of a histogram to have a sense of what the distribution of data looks like. And here we're going to start with this. Alright, so this one is pretty easy. We are going to just call plt.hist, and the documentation for this says that compute and draw the histogram of x. So x is actually going to be our data. I'm going to make a histogram of the price and just run this. Okay, so you see that there is some output from this one, and then the chart is shown, but I would like to suppress the output and just show the chart, so I'm using a semicolon here. And this is pretty much the data, and this is pretty bad initially. So one thing that you can do is actually to increase the resolution of this chart, and you can say that you want the number of bins to be, let's say, 50. And now you can see that we have more bins in this histogram. One thing that you might notice is that this histogram is spanning across up to 10k dollars. This is basically this is price per night. So we have some properties that are very, very expensive, and they are what you might say outliers. So you can't basically have a look at this data in here. And there are basically two ways to handle the situation. You can limit the x-axis, and you can say that you want from 0 to 500. And now you get a zoomed in picture of the data. But notice that this is not increasing the resolution of the bins. You are still getting the same amounts of bins, and you're just basically zooming in into the chart. Another or better way to do this is to basically get a subset of the data. So let's say that I want to look at properties that are $500 per night or less, or just less than $500. I can filter based on the price. I can filter our data based on the price, and then I can plot just this one. Okay, so you see that, let me decrease the resolution in here, so you can now have a much better picture of what is going on in here. One thing that you might notice is that we don't have any labels on the X, Y's, and we don't have a title. Let me fix this. We can add a title. This will be the property price. I can set a label for the X-axis, and this is the price. And for the Y-axis, I'm going to say that this is the number of properties. And I'm going to suppress the output once again. And now we have the title in here, the price here on the X-axis, and on the Y-axis we have the number of properties. So this looks like a very good chart indeed. Okay, so the next thing that you might wanna try is to have a look again at the distribution of the prices using something that is called a box plot. And this one is going to be really the same thing, but I'm going to just say box plot here, and we don't have bins. So this is pretty much the same chart, but you now get a sense of what the mean value is, and it's $100. Of course, that this is based on the price on properties that are under $500, and of course the mean would be much higher if we include the outliers. So we have the mean, and these are the values within one standard deviation, I believe, and those are within 2 or 3 standard deviations. I'm not so certain about those values, but you kind of get the different amount of values that you get in here. And the distribution says that there are still some values, but they are not that many, which are covered within the 300, let's say 20 up to 500. And you can double check again with this chart here, and this pretty much tells the same story. So this is just another way to look at the data. Okay, so the next thing that you might wanna have a look at is, based on the neighborhood group, we would like to tell what are the prices, or does each individual neighborhood group has different prices, something that you might expect actually. And to check that, I'm going to use a Violin Plot. And this one is going to be provided by Seaborn. I'm going to do a chart using the neighborhood group and then the price. And I'm going to basically copy and paste the title and labels here, but I'm going to say property price per neighborhood. Let me not type this. And this will be the price. And this is the chart. And this chart, of course, on the x-axis we have the neighborhood group, and on the y we have the price. And this chart is very good at showing you something similar to the box plot here. But the wider this chart is, the more data points you have in this price range. So you can basically see from here that Queens, Staten Island, and Bronx and are roughly in the same price category. There are still some more expensive properties here, but not so much, at least, of course, not for Bronx. But in Manhattan, you can see that the prices are actually might be very different. And in Brooklyn as well, it looks like, yeah, Brooklyn is still an expensive neighborhood that you can get a place in, but there are examples in Brooklyn that obviously are very cheap, at least compared to Manhattan. Okay, so the next thing that you might want to have a look at is the number of properties per each neighborhood, because, yeah, here we are using just the prices. But now we would like to basically say, okay, so the prices are ranging that much, but how many properties are available for renting at each neighborhood? And we can do that using a bar chart. And this bar chart is going to contain a bar which contains the number of properties per each neighborhood. And to do that, I'm going to take a shortcut, use Seaborn count plot. And do this. Okay, let's make this a bit better looking. I'm going to just copy and paste the title and labels, because we already know how we can do this. And you can see that you can compare this to the Violin Plot. In here you had no idea how many properties there are in each neighborhood group, but in here you can clearly see that we have very little properties in Staten Island and Bronx. So the data for the prices might not be, you might not trust the data for the prices in those neighborhoods. At least the variance might be very large because you have a lot of uncertainty. While Brooklyn and Manhattan have the majority, I would say maybe 80% of the properties are in those two neighborhood groups, which is expected because they're probably the best neighborhoods that are available for tourists, I guess. Queens is next. We have about 5,000 properties in here, and this is based on all of the properties that we have, not those just under $5,000. And if we go ahead and check this one and plot the Violin plots, you can see that the price ranges are very highly skewed, and this is not useful at all. Okay, so we have those, and next I'm going to show you how you can plot the median price per each neighborhood group, and I'm going to do this using a line chart. And I'm going to take the median price for each. Let me use the complete data. I'm going to take the neighborhood group. I'm going to basically group the data by the neighborhood group, and then I'm going to take the median price using pandas, and I'm going to just plot this. Alright, so we have the median price. Of course, that's not the mean price, and this should be much more robust to outliers. Let me just take the labeling for this chart. Alright, you can see that again Manhattan is having the most expensive properties with a mean price at roughly 150, and Brooklyn is much cheaper, and of course Bronx is the cheapest, and Queens and Staten Island are roughly at the same median price. Sorry. Okay, so we got the intuition that the prices in Queens, Staten Island and Bronx are relatively cheaper compared to Manhattan and Brooklyn, and we have a lot more properties in Brooklyn and Manhattan. So at this point you know that your dataset is very highly imbalanced in regards to the neighborhood group prices, because you have a lot of examples for Brooklyn and Manhattan and not so much in Queens, Staten Island and Bronx, which is again to be expected in this case. Alright, so the next thing that I'm going to do is to show you a scatter plot, and this one is going to explore the prices of the prices compared to the number of reviews. So does the number of reviews affect the prices and vice versa? And to do this, I'm going to use plot.scatter, and for the x value I'm going to use normal price df price, and for the y value I'm going to use normal price df number of reviews. And if we just get the labeling for this, and do the scatter plot, you get pretty much this. And yeah, there is some trend that the number of reviews are actually doing something, and it looks like that the less reviews you have, the more expensive the price is, which is again expected, because yeah, it's relatively hard to get tourists to pay the highest amounts of prices, and the cheaper places have a lot of reviews, and maybe they're getting a lot of business based on this. Okay, so but this one is relatively not, well, it's really hard to look at this. You can't see how many points are actually in here, because, well, everything is just blue. So you can use some sort of a hack, and you can basically take a sample of the data. I'm going to take 10,000 examples. And if you plot this, we still get the same thing. So there is another way to accomplish this, and we are going to use basically, we are going to draw basically a heat map on top of the scatter plot. And for this purpose, I'm going to use the Gaussian. Is this one? Yep. Gaussian KDE, and I'm going to show you how you can use this to make this sort of heat map. Here I'm going to stack vertically these two prices, the prices and the number of reviews. And then I'm going to create a Gaussian KDE. I'm going to pass in the stacked array here and apply it on the same array. Then I'm going to use the price, the number of reviews, but here for the C or the color, I'm going to use the result of the Gaussian KDE, and I'm going to set a marker size in points, which is going to be a much larger circle in our example. And the result is basically again a heat map on top of this scatter plot, and you can clearly see that we have very large amounts of points in here. A lot of the properties have 0 or maybe 5, 10 reviews, and most of the properties are very well stacked in here. So this heat map is showing basically the intensity of the number of reviews that we have here. So the most properties are lying within the under $100 per night, and most of those don't have any reviews or close to 1-2 reviews actually. Alright, the final plot that I'm going to show you before basically showing you how you can load and show an image is going to be a stacked bar plot. And I'm interested in the room types because if you recall, we have the neighborhood group and the room type. We have private room, entire home or apartment, and maybe some others we're going to see in a bit. And I want to see what type of rooms there are for each neighborhood. And to do this, I'm going to basically create a data frame which is grouped by the room type and neighborhood group. Then I'm going to take the size of it or the shape of it, reset the index, and create a pivot table, which I'm going to show in a bit. And the pivot table is going to contain columns from the room type and index on the left for the neighborhood group, and fill the missing values with 0, which hopefully shouldn't be necessary. And if I show you this plot, you can see that we have this pivot table, which basically shows you the counts for the different room types. We have 3 different room types for each neighborhood, and you can plot this relatively easily using dfplot.plot.bar. I'm not that I'm using the pandas plotting capabilities. I'm going to stack those and rotate the labels, and I'm going to paste in the labeling, and this is the chart that we get. So from this one you can clearly see that most of the Manhattan and Brooklyn, let's say that most of the Manhattan properties are actually entire homes or apartments. In Brooklyn we have roughly the same amount of entire homes and private rooms, and of course we have some shared rooms in both Manhattan and Brooklyn, while in Queens and Staten Island and Bronx we have almost always only private rooms and entire homes. And of course on the left you can see that we have a number of properties here. So this is pretty good graph, I would say. So you can explain the higher prices in Manhattan based on the fact that except for the location, you have most of the properties in there are actually entire homes or apartments, so you can expect those to be more expensive. The last thing that I'm going to show you is how you can show an image using Matplotlib. So when you're working with computer vision or other tasks, you might wanna have a look at how you can do this, and this is relatively easy. First, I'm going to download an image, and it's called stop sign JPEG. I'm going to open it using Peel Image Open. And if we print this out, you can basically show it like this. But if you wanna have a look at how you can do the basic plotting using Matplotlib, so it would respect the sizes that you want that you've given at Matplotlib, you can do this, and you are seeing the grid in here, and you can turn this off by disabling the axis. And I'm going to suppress the output, and this is the final image, which is respecting the sizes that you've given in the RC params. So this is pretty much it. These are the most common operations that you're going to do when you're trying to do some plotting or data visualization, data exploration. Thanks for watching, guys. If you'd like this video, please share, like, subscribe, and I'll see you in the next one. Bye.